So hello, and today we're going to look at graphing transformations. We'll break this up into two videos. One will consider each of the four separate transformations, and the second video will put them all together and give you an idea of how you graph them when you have several transformations in one. So let's begin by just looking at a graph of sine. And as we said before, everything that we do with sine we can do with cosine. They really are essentially the same graph. So let's put up a graph of sine. Okay, so here is a graph of good old sine. Y is equal to sine of x. And the first transformation we want to look at is what happens if we put a number right in front of sine of x. And what you should remember from previous courses is that what we're doing here is multiplying the y value by some number. If that number is bigger than 1, it's going to stretch this graph in both directions. If that number is less than 1, it's basically going to compress the graph. The domain is certainly not going to change. It'll remain all reals. But what's going to happen is the graph will either be stretched vertically, getting larger, or compressed vertically, getting smaller. So let's look at a couple of examples. So what you see in front of you are three graphs. All of them have to do with sine. This one in the middle, that looks like a purple, is good old sine of x. The one that goes up all the way to 2 and down to minus 2 is y equals 2 sine of x. And finally, the one that is the smallest of all in terms of its height, that one, let me see if I can give a different color, that one right here is y is equal to 1/2 of sine of x. So as we expected, in each case, what we're changing is the height, and the fancy math word is amplitude. So the amplitude for y equals sine of x is 1. The amplitude for y equals 2 times the sine of x is 2. And finally, the amplitude for 1/2 times the sine of x is, right, 1/2. So that's the idea of amplitude. And it's pretty simple. What we're doing there is changing the range. The range of sine of x is -1 to 1, but the range of 2 sine of x is -2 all the way up to 2, and the range of 1/2 sine x is just right here, -1/2 to 1/2. Okay, so let's keep going. So previously we saw that if y is equal to a times the sine of x, this affects the range. And the range actually is just going to be -a to a. Another way to change the range is if we talk about sine of x plus d. And again, you should remember from previous math courses that this is a vertical shift. In other words, it takes the whole graph either up or down, depending upon the sign, the sign of d. So we'll just understand this by looking at a couple of graphs. Okay, so here you see a lot in front of you. Here in purple is our regular sine graph. Now, if we think about what happens when we take sine of x and add 2 to it, the entire graph is just jerked up 2 units. And so our new range is going to be, if you can see it, from 1 to 3. It's the old range, which is -1 to 1, and then you simply add 2 to each of those. sine of x minus 1, everything gets moved down 1. And that also affects the range. So if I, let's see if I can add this in here. Here's my range. So here the range is going to be from 1 to 3, minus 1 to 1, and here it's minus 2 to 0. So to kind of just summarize a little bit here, if we take these two actions, a times the sine of x plus d, both of these are going to change the range. So what we'll do next is look at things that change the domain, or not really to change the domain, because the domain is going to remain all reals, but have an effect on the domain. So here we look at what happens when we multiply x by a constant. And again, if you can remember back to your graphing transformations from Algebra 1 and Algebra 2, what this b does is a horizontal stretch or compression. And we'll see that again with a couple of graphs. So this is a bit of a dizzying graph. Here is sine of x, and here is the sine of 2x. So take a few seconds. You might want to press the pause button and see if you can kind of recite in words what effect that 2 has. Okay, and what you should have realized is that it changed the period. And the period of sine of 2x is just pi. And we get that by taking the period of the original graph, which is sine of x, and dividing it by b, which in this case is 2. And so what you want to think about then is, what about if instead of a 2x, I had the sine of, say, 1/3 x? Can you guess what that's going to be? Take a second and let's see if you can guess it. Okay, so here we've graphed sine of x and then the sine of 1/3 of x. And can you see what the change is? Once again, the period has changed. And one full cycle of sine of 1/3 x goes from here to here, from minus 3 pi to 3 pi. And so what we recognize is this, that the period of sine of 1/3 x is 6 pi. And that's really the same as 2 pi divided by 1/3. And so that's our rule, that if we have y is equal to the sine of b times x, the new period is equal to 2 pi over b. And so what we get when we multiply by this b is we either stretch the graph horizontally or compress it horizontally. And it's all determined by b and determined by this formula. Okay, got one more thing to look at. So once again, I'm sure you're getting tired of hearing this, but you have seen this kind of thing before. And what this results in is a horizontal translation. So just like adding something on the very end causes the graph to go up and down, adding something in here, inside the function, causes the graph to go either left or right. So once again, we'll understand this by looking at some graphs, and we'll get the hang of it pretty quickly, I think. Okay, so friends, I believe a picture is worth 1,000 words here. So again, in purple, we have the standard graph of sine of x. Now I've graphed the sine of x plus pi over 2, and that's right here. And can you see how it moves? Take a second, press pause if you want, and see if you can come up with a guess. Yes, that's correct. Good guess. Y equals the sine of x plus pi over 2 is the same as sine of x shifted pi over 2 to the left. And just notice that the sine of x plus pi over 2 is the same as the graph of what? Exactly, cos of x. And that helps you see that really sine and cosine are very closely related. So that puts it all together, and let's just summarize that in a second. So here's the most complicated way of looking at this. And all we'll do right now is just talk about what these constants do. So this affects the amplitude. And this is a vertical shift. And they both affect y values. And in particular, they affect the range. Now, the b changes the period, and the c is a horizontal shift. And what we see is that both of these affect the x values. Okay, and in the next video, part 2 of graphing transformations, we'll see how we can take something that looks as complicated as this and make it be really simple. And just in passing, remember that everything we did with sine is exactly the same as cosine. In fact, sine and cosine are simply called sinusoids. Okay, that's it for now. See you next time.